Smart composting system is made up of a number of components. The first is the main system that has a temperature system, moisture sensor, water float sensor, ambient temperature system, kind of so Arduino there, as well as a methane sensor. It's got two actuators. It's got an air vent that's controlled by a servo, as well as a water pump which hydrates the compost when it is dry. Second piece is the kitchen bin. That is a smart kitchen bin with a Arduino attached to the back. Has an ultrasonic rangefinder attached to the top of the bin along with a read sensor. So when it opens, it measures how much is in the compost. And finally, all of the data is crunched with that Intel Edison that provides the analysis, provides recommendations to the users, and hosts up the website. Just here's me putting one of the water hoses in. So I built it so that it's easy to insert.
So here is the prototype, the very messy prototype of the smart compost system. If you don't know, composting, there's quite a bit of science to it. Compost needs to be between 110 and 140 degrees Fahrenheit to be most effective. It also needs to be between 40 to 60% moist, so 40 to 60% wet, soil does, in order to make effective compost. For composting, we're looking for an aerobic, an oxygen-driven process versus an anaerobic process. The anaerobic processes like landfills, those cause methane spikes. This, with oxygen, actually uses that oxygen with the nitrogen in the compost to break down the soil quickly and then have less of a negative effect on our environment. So let's talk about our smart compost system. It's made up of 4 different sensors. We've got the temperature probe, which we use to measure the temperature clearly, the moisture sensor for moisture, the methane sensor, and then an ultrasonic rangefinder. And we'll talk about that in a second. And in addition, we've got a couple of actuators as well. We have a servo. That servo is going to be attached to a pipe and it opens and closes based off of if air is needed. And then there's the pump. So there's a water pump that pushes water into the compost if there's not enough moisture. And this ultrasonic finder, it goes on top of a rain bucket or something sitting outside of the compost, and it would let the user know if more water was needed. So all these components you see are put out here. So we see our temperature is about 115 degrees. We have no moisture, which just makes sense because we don't have that moisture sensor in anything. Our methane's 13.9 ppm, which is just fine. That -1 means that we need water, which makes sense because we have it showing in an empty cup. And then the servo is marked at 0. That means the servo is closed, the vent is closed. Now I will show some experiments over with some of the hot and the cold water to show you what happens as you make changes. Now the first thing I've done is put the moisture sensor in water. That is going to register that the soil is too wet, and this servo is going to turn open. In theory, the servo is going to be attached to a pipe which goes through the compost, and there'll be a cap on top, and if this is closed, then this will move open and we would allow air to get through the compost. And as you can see, the servo has moved to open, and it's hard to tell now, but this again will be attached to a pipe, and if the pipe is on this side like this, then the cap will have switched open. Okay, so I've done a couple of things. I've taken the moisture sensor out the water, so it's sensing dry. I've then filled up this cup with water, so the ultrasonic sensor believes now that that there's water available, and the pump is here, and in a few minutes we should see the water going from the pump into the cup. So as you can see, we've added more water to the pipe. It was dry, we need that. And also, our servo moved back to being closed because our temperature is getting too cold. So I've moved the temperature probe out. It's now below the optimal temperature, therefore it's closing because it needs to, we're getting too much air in the compost. So the next time you see these components, they will be in our prototype soil, in our prototype container, and we will measure for a few weeks, see what happens.